begin with a small tech talk from QJ Consulting. Before that, I would like to welcome our guests, Mr. Pradeep Nair, Mr. Debarga Mitra, Mr. Rajiv Rai, Ms. Surabhi Rai Chaudhary, and two of our former students, Mr. Shubhajyoti Maiti and Mr. Anirban De. I would now request Dr. Joydeep Mukherjee to please felicitate our guests with a small token of appreciation and gratitude. একটা একটা করে দিতে এই এই Without any further ado, I would like to call upon our speakers for today, Ms. Surabhi Rai Chaudhary, Mr. Shubhajyoti Maiti, and Mr. Anirban De.
Good afternoon, everyone. Before we begin with our presentation today, I would like to thank the entire Perceptron committee and faculty members, especially Maharaj, for adjusting the timing for us. We are delighted to introduce our team members, Mr. Pradeep Nath, the director of our organization, along with Mr. Rajiv Roy, who is a part of our senior management, and my fellow colleagues, Anirban De and Shubhajyoti Maiti, who have joined QJ in June, and alumnus of this university, me, Surabhi Rai Chaudhary, and Debarga Mitra. At QJ Consulting, we uniquely combine deep hands-on experience from the world's top consulting firms with a fresh perspective of dynamic young talent. Together, we deliver robust, both traditional and innovative solutions to meet diverse business challenges. As team members of QJ Consulting, we are committed to pushing the boundaries of what's possible in business consulting. In the 30 minutes time slot that has been provided to us, we'll showcase some glimpses of our solutions and prototypes. Our first solution is about a smart tea garden management and pest control dashboard, along with a geofencing and disease spotting application. We all know that managing a tea garden effectively requires constant vigilance and precise decision making, especially when it comes to pest control and resource allocation. We have developed a spotting and geofencing application coupled with a powerful AI-based garden management solution which provides a comprehensive summary for tea garden management. It enables the decision makers to monitor every aspect of the tea garden operations remotely, ensuring that no section of the garden is overlooked. This integrated system offers real-time tracking of spotters, detailed analysis of pest outbreaks, and insights into pesticide spraying activities. With features like geofencing, performance tracking, disease summaries, and pesticide usage tracking, it empowers owners to take data-driven decisions to maintain garden health, enhance productivity, and optimize workforce efficiency, all from the comfort of their office or home. This is our spotter activity page. From a business perspective, as a decision maker, it is challenging to monitor every section of the garden personally, especially when dealing with large estates. This page bridges that gap by providing you with real-time insights into the activities of spotters, ensuring that every corner of your garden is covered and no pest infestation goes unnoticed. On the map, the blue dots represent the locations traveled by spotters, while red dots indicate sections where diseases have been identified. This visual representation allows you to track the efficiency of spotters remotely and pinpoint critical areas needing immediate attention. Hovering over the red dots provide detailed information about the specific diseases spotted, enabling you to make data-driven decisions on pest control measures. On the right, there's a summary table that categorizes sections into live spotter route, no pest found, no plantation area, not surveyed areas, pest found areas, and pruned areas. With date filters, you can get a day-wise overview of your garden's health and ensure that all sections are adequately surveyed and categorized. This helps you to identify patterns and gaps in coverage, improving operational oversight. Additionally, we have a spotter performance matrix table where you can select a spotter and view detailed performance matrix, including their assigned sections, the distance they traveled, the area they covered, and their zone status, whether they stayed inside the section, ventured out, or patrolled the perimeter. This information helps you evaluate the effectiveness of your workforce and optimize resource allocation to ensure maximum efficiency. Finally, the disease summary table provides an overview of the identified diseases, including section names, spotter IDs, disease types, and captured images of the affected areas. This allows you to analyze trends in pest infestations, focus resources on the most affected areas, and ensure timely intervention. This is our home page, which offers a comprehensive overview of the tea garden's health and operation. The map provides an overall garden zone summary, categorizing sections into live spotter route, no pest found, no plantation area, not surveyed areas, pest found areas, and pruned areas. This categorization ensures that as a tea garden owner, you can quickly identify areas requiring immediate attention, such as pest-affected sections or zones that haven't been surveyed, helping you prioritize actions and allocate resources effectively. In the spray analysis section, the dashboard provides an in-depth overview of pesticide spraying activities, which can be filtered by disease names, gardens, sections, divisions, and even months. This level of granularity ensures you can track trends over time and identify potential inefficiencies or gaps in spraying coverage, such as sections that are undersprayed or oversprayed, leading to unnecessary cost or ineffective pest control. To further enhance decision making, diseases are categorized into groups like new outbreak, persistent infections, returning infections, and successfully treated. This allows you to evaluate the effectiveness of pest control measures over time and focus on persistent problem areas. For instance, sections where recurring infections may indicate deeper issues such as ineffective pesticides or poor follow-up, which can then be addressed proactively. The garden code-wise spray activity counts provide a breakdown of the total sprayed area in hectares, the most spread diseases, and the ability to drill down into section-level details. By selecting a garden or division, you can access specific metrics such as disease-wise spray activity count, their percentage contribution to the total activities, total sprayed areas, and the number of infected sections with corresponding percentages. This feature ensures you can evaluate the return on investment for spraying activities and target resources where they are most needed. Additionally, the section garden division-wise monthly spraying activity table offers a detailed summary of spraying activities categorized by disease statuses like new outbreak, persistent infections, returning infections, and successfully treated. By selecting specific sections, gardens, or divisions, you can drill down to view monthly activity counts, disease-wise spraying details, pesticide names, and specifics such as quantity and dilution. This ensures that you have complete transparency into operations and can detect inefficiencies such as misuse of pesticides or inadequate coverage. To make the data even more actionable, sections are categorized by size, large, medium, and small. This allows for more precise resource allocation and ensures that smaller sections which may be overlooked get equal attention. This is our sprayer activity monitor page where we can analyze the month-wise activity of sprayers, offering tea garden owners a detailed view of their workforce efficiency and spraying effectiveness. The table displays the number of active sprayers for each month. By selecting a specific month, you can dive deeper into essential metrics such as sprayer names, the number of divisions covered, total area sprayed, and the total time spent in hours by each sprayer. This helps identify underperforming sprayers or areas where resources might be misallocated. For example, if a sprayer consistently covers fewer divisions or sprays less area compared to others, it could indicate inefficiency or operational issues requiring attention. By drilling down into a specific sprayer, the dashboard provides details about their assigned sections, divisions, and gardens. It also includes date-wise information such as area sprayed, divisions covered, and time spent. This level of detail allows garden owners to monitor whether sprayers are effectively covering their assigned areas and to detect deviations from their routes. Such insights ensure accountability and prevent sections from being missed or poorly managed. Additionally, the dashboard includes comprehensive data on the pesticides used, allowing garden owners to monitor spraying activities by sprayer name, date, section, garden, or division. This ensures better pesticide management, enabling owners to detect inefficiencies such as overuse or misuse of chemicals, which could lead to unnecessary expenses or environmental concerns. The page also features a daily summary table offering a snapshot of the number of active sprayers, divisions covered, total area sprayed, and the total time spent by sprayers on any given date. This information can be further drilled down into sections, divisions, and gardens, providing a compact yet comprehensive view of daily activities. This ensures that no day goes unchecked and helps in tracking progress on a more granular level. From a business perspective, the page addresses critical concerns such as resource optimization, workforce accountability, and pesticide effectiveness. It helps identify potential loopholes such as the sections that are left unsprayed, which could lead to pest outbreaks, sprayers deviating from their assigned routes resulting in inefficient operations, unequal workload distribution, which could impact overall productivity. By detecting these issues early, one can take proactive measures to ensure optimal resource utilization and effective pest management, ultimately reducing costs and improving crop health. This structured and data-driven approach empowers garden owners to stay in control of operations remotely, ensuring consistent performance and higher profitability for their tea gardens. Inventory dashboard. In the next part, we'll dive into the transformative potential of advanced analytics in inventory management. I'm excited to introduce a cutting-edge dashboard designed by me and our team lead Paramita ma'am to not only optimize but also revolutionize the way businesses manage their inventory and maintain sales operations, even in challenging circumstances such as raw material shortages. This dynamic tool is crafted with the intent to prevent disruptions and ensure a seamless flow of business activities. By leveraging state-of-the-art machine learning models, which predict sales with an impressive accuracy of 96%, our dashboard provides invaluable foresight into future sales and stock requirement. This proactive approach allows companies to prepare and adjust their strategies effectively, preventing potential sales loss and operational hiccups. The dashboard is designed to maintain uninterrupted sales operations in case of raw material shortages, ensuring smooth flow of businesses. The Pareto chart shows the priority products that contribute to 95% of sales. Before delving into the alert messages, let us understand how the system works by looking at a particular product. We click on a specific product name, which will show its sales forecast for the next 3 months. In the past sales and projection graph, the green line represents the past sales and the red line represents the forecasted sales, which is predicted by a machine learning model with 96% accuracy. This shows the projected amount for the next 3 months. This shows the total stock in hand. This shows the amount of goods that needs to be produced and meet the sales for the next 3 months. This is a list of ingredients required to produce the product. This is the quantity of ingredients required to meet the demand and sales values for the next 3 months using the simulation button. The simulation button won't work right now since it's not connected to a server. It needs to be connected to a server for the simulation button to work properly. Upon triggering the flow, the system engages in iterative recalculations, leveraging the provided input to generate revised required quantities. Whenever a new item gets added, an email alert will be triggered to the respective shareholders. To check the item with crucial shortage status, you have to click here. This will open a page where you can see its ingredients, its stock in hand, and the average delivery day required for the ingredient. To check the stock status of a particular product's ingredient, just click and drill through. This will open a page where you can see the stock status according to its lot number and location. To check the supplier score and supplier profile of any ingredient, click and drill through. This will open a page where we can get detailed information about suppliers. The supplier with highest score is suggested based on several parameters. Our next solution is a peer processing solution. From our experience with ERP systems, we have observed that a lot of time is lost in manually entering data into ERP. This not only consumes valuable time, but also increases the risk of data entry errors, which affects the ERP system's efficiency. Since data is the key to any decision-making, reporting, planning, and evaluating the performance of an organization, it is always prudent to ensure that the entire process is error-free. We have bridged both time and error by developing a solution that we are excited to demonstrate to you today. This application allows users to upload multiple page invoices in formats like scanned PDFs and images. Using the model, it extracts key invoice details, including product's name, quantities, tax rates, and total amounts. Extracted data is pre-processed into structured data frames and combined for consolidated analysis. A tax calculation module computes CGST, SGST, and IGST for each line item, ensuring accuracy. The system validates invoice totals, labeling them as C correct or P problem for further resolution. By clicking on the peer selection dashboard button, the next page opens, allowing the user to upload multiple invoices in various formats, including scanned images, PDFs, and image formats. By clicking the Browse Files button, the user can upload multiple files simultaneously. We send the input question, prompt text, and input image to the Gemini model to extract text relating to invoice details, such as invoice number, invoice date, supplier name, GSTIN number, product, quantity, GST, discount rate, tax rate for each product, entry and total amount. The prompt text is carefully designed to ensure that the model understands the input and extracts relevant invoice details accurately. It is structured to guide the model in returning a clear, organized response containing all required fields. By implementing several pre-processing steps, including NLP techniques, we have extracted the relevant part from the Gemini model's response. These have been converted into a suitable data frame. Finally, we have combined them into a single data frame that consolidates all processed files. Here we incorporate the module that performs automatic calculations of all applicable taxes, CGST, SGST, and IGST for each line item, ensuring tax representation. We check the invoice amounts against the combined total of line items and taxes. We label them as C, correct, if they match, or P, problem, if there are differences. The invoices flagged as P are resolved manually. We successfully extract invoice details, achieving the desired field accuracy in at least 94% of the PDF files processed, spanning various formats. The 6% discrepancy results from blurry images, calculation errors in the invoices, or additional charges applied to certain invoices. Thank you, everyone. These are the works that QJ has been associated with. We are working more on other projects as well. So feel free to ask any questions, and if you have queries, then you guys can ask us.
Gemini 1.5 phase.
Depends on the project. Which project are you talking about?
Related to AI.
Okay, the tea garden management. So it's a simple dashboard. We didn't use any machine learning models behind that. Yeah. So are you talking about the second one? Okay, the inventory management dashboard. Yeah, so there we have used multiple machine learning models. Like for example, we have used VAR, we have used Sarima and Random Forest. But Random Forest worked the best, so we have used Random Forest. It's our own data. Yeah. Thank you, everyone.